Welcome, Friday Chemistry, end of the week. All right, Unit 9, we're into our fourth lesson on Unit 9. It's going to be the good stuff today. So, let's get into it. Today, all right, we're specifically talking about molarity. All right, we already talked about percent by mass, percent by volume, molality, mole fraction, all that. So we're going to talk about molarity today. And then we're going to do some molarity math, which involves when you're given the concentration of two solutions, can you determine the concentration of the new solution when you mix them? All right, that sort of thing. So, molarity, definitions, and molarity math. That's what we're doing. All right, let's get into it. Remember the definitions of all these different concentrations. The top one's the one we care about today, and it's molarity. It's the most important one. If you don't remember any of them, well, then you're going to do poorly on the test. But if you only remember one for the rest of your life, it's molarity. That's the most important one. So, molarity is moles of solute divided by liters of solution. So it's moles and liters, and it's solute and solution. Remember, in the example of salt water, the solute is salt, the solvent is water, and the solution is the whole salt water. So we're taking the solute and the whole solution. Unlike molality, which is the solute and the solvent. Molarity is the solute and the solution. All right, keep that straight. So, first up, molarity. Well, let me get rid of myself here. Goodbye. So, it's important to remember that in the lab, all right, you got to consider the amount of room your solute takes up in your solution. All right, if you need a 1 liter of 1 molar solution, you can't just start with a liter of water because the salt you add is going to add some volume to that. All right, so it's important to remember it's the volume of your whole solution, all right, not just the volume of your solvent. So, definition of molarity. Molarity is moles of solute divided by liters of solution. Molarity is a measure of concentration, just like all of these things we've been talking about in Unit 9 are measures of concentration. I have an example, all right? So I've made 2 solutions for you. It's copper sulfate. One is 1 molar. That means 1 m, so it has a molarity of 1. The other is 5 molar. All right, it means it has a molarity of 5. You can see the difference in concentration in these solutions. All right, here's an example of a 1 molar solution. All right, here's an example of a 5 molar solution. All right, very different as you can see. All right, the 1 molar solution, you can see the concentration is much more dilute. All right, it's very dilute. And the 5 molar is very concentrated. And that's what molarity means. As the number goes up, it gets more concentrated. As the number goes down, it gets more dilute. So this is high molarity, this is low molarity. All right, so that's what molarity means. That's the definition of molarity. Now let's get into the good stuff, the math. So I could ask you a question that says something like, what is the molarity of a 1.6 liter solution containing 1.55 grams of potassium bromide? Now note, all right, it's liters of solution. It doesn't matter what solution. All right, so I didn't tell you, but it doesn't matter. It's probably water. It's usually water, but it doesn't matter. So we need to find a couple things. We need to find our moles of solute and our liters of solution. Well, we know we have 1.6 liters of solution. That's taken care of. But we have 1.55 grams of solute. That's not moles, it's grams. So we're going to have to go from grams to moles, and we can do that. We've done it a bunch. We're going to do it again. You just take your number of grams divided by the molar mass of the thing. Remember that the molar mass of the thing comes off the periodic table, or you can ask your smart home device and it'll tell you if you got one of those. So let's take a look here. To find the moles of KBr, we're going to take 1.55 grams, because that's what it gives us, divided by the molar mass of KBr. K, potassium, is 39.10 grams per mole, and bromine, Br, is 79.90 grams per mole. Well, we add those together, and in your scientific or graphing calculator, you take 1.55 divided by parentheses, 39.1 plus 79.9, and you get 0.013 moles of KBr. All right, we got our moles now, and we got our liters. Well, molarity is simple. You just take moles divided by liters. So we'll take 0.013 moles of solute divided by 1.60 liters of solution. And when you plug that into your calculator, in this case, no parentheses needed, you get 0.008125. Now, since we're rounding to 2 decimal places, you need to round that, so we'll get 0.01 molar. Right? The molarity is 0.01. Right? When you talk about molarity, we use the word molar. So this solution is a 0.01 molar solution of KBr. That's what it means. The unit is capital M, where molality was a little m, molarity is a big M. All right, so the steps are convert grams to moles if you have to, then take moles of solute divided by liters of solution. That's simple. All right, so we're going to do some practice problems. Make sure you have the steps here in the example written down, and then let's move on to the practice. All right, 3 practice problems, because molarity is the most important thing we're doing this unit. So it's important that you know how to do it. Let's talk about these problems. We've got problem number 1, 100.5 milliliter solution with 5.10 grams of glucose. Wants to know the molarity. Well, I'm giving you a little help here. I already calculated the molar mass of glucose for you. You don't have to look it up on the periodic table. It's 180.16 grams per mole. And you'll notice, all right, instead of giving liters, it's giving us milliliters. Well, it's important to know that 1 liter is 1,000 milliliters. So here, our 100.5 milliliters would be 0.1005 liters. So you'll take your grams divided by your molar mass to get moles. Then you'll take moles divided by 0.1005 liters. All right, that's number 1. Number 2, we're going to find, in this case, not the molarity. We're going to find the mass. All right, we're given the molarity and we're given liters. Now remember, molarity is moles divided by liters. Here it's giving us moles and liters. And we need to find, sorry, it's giving us molarity in liters, not moles. We need to find moles in order to find grams. So here's what you're going to do. All right, 3 equals x over 0.25. So 3 times 0.25 equals moles. All right, you're going to get moles, and then you're going to take that times the molar mass of NaOH to get grams. That one's sort of backwards, but you got to be able to rearrange these equations. And thirdly, a very straightforward one. All right, we have 9.5 grams of solute, in this case NaOCl. You'll need to find the molar mass of that and take 9.5 divided by that molar mass to find the moles. And it says per liter. Now this is an example of some interesting vocabulary you might see on the questions, but per liter just means 1 liter. All right, so you'll find your moles by taking grams divided by molar mass and then divide by 1, which is the same number. So 3 different problems, 3 different ways of looking at it. It's going to take a couple minutes to do this, all right? So make sure you have the previous example written down. Make sure you have the equation, M equals moles of solute divided by liters of solution. And work through all 3 of these problems after you pause the video. So take a minute, pause the video, work through these problems, and then we'll come back and find the answers together. I'm going to pretend you actually paused the video and worked through them. I know some of you did. And let's take a look at the answers. All right, the first one, 0.28 molar. That's because 5.1 divided by 180.16 divided by 0.1005 is 0.28. I had to do all that on my calculator. You can do it on yours. Secondly, all right, we find that it's 30 grams. I gave you a little bit of work here. All right, 3 molar equals x divided by 0.25 liters. Well, that means x is 0.75 moles. 0.75 times 22.99 plus 16 plus 1.01 off the periodic table is 30 grams, 30.00 even. Neat how those work out when you write them yourself. Finally, all right, what is the molarity of a solution containing 9.5 grams of NaOCl per liter? Well, I just took 9.5 divided by 22.99 plus 16.00 plus 35.45. All those numbers come from the periodic table, and I got 0.13 molar. All right. That's molarity in a nutshell. If you didn't get those answers on the practice problems, go back to the example, rewrite all those steps out, and try it again. Remember, if you have questions about how this works, you can email me anytime. And, you know, if we need to set up a video chat with a couple students, we can do that Tuesday through Friday from 1 to 3 p.m. That's when I'm free. So, feel free to email me with any questions. Let's move on. The second thing we're doing today is just some more molarity, but just slightly different. Right? we can dilute molar solutions. All right, let's talk about dilution of molar solutions. There's an equation here. It's M1V1 equals M2V2. Now, any of you who take chemistry in college will use this a bunch, so it's important to remember this. M1V1 equals M2V2. M means molarity, V means volume. 1 means the first solution, 2 means the second solution. So, in long form, the molarity of the first solution times the volume of the first solution is equal to the molarity of the second solution times the volume of the second solution. So, if I have 5 molar 1 liter, and I dilute it to 5 liters, it would become 1 molar, because 5 times 1 equals 1 times 5. All right, that's what this is saying. It's saying if you add water, all right, how much does the molarity change? Or if you remove water, how much does the molarity change the other way? All right, if one goes down, the other goes up. It's an inverse relationship. So, let's take a look at a practice problem or an example problem, and then we'll move on to the practice and so on. So, first up, example problem. All right. What volume of 2 molar CaCl2 would you use to make 0.5 liters of 0.3 molar CaCl2? Well, it's saying what volume of this. So, M1 is 2.00 molar. V1 is our X, right? It says what volume, we don't know. Right? And it says it makes 0.50 liters, that's V2, and 0.3 molar, that's M2. So let's plug all of this into equation for clarity. So M1, 2 molar. V1 is our variable. We're solving for it. Right? M2, 0.3. And V2, 0.5. All right. So we plug all that into the equation. We can plug it all in here without the labels, just for a little mathematical clarity. And we can rearrange the equation to solve for V1. The way you can do that is divide both sides by 2 molar. All right, you divide both sides by 2 molar, you'll get V1 by itself. All right, all diluting molar solutions it's just algebra. Right, it's one variable algebra problems. You just got to rearrange the equation. All right, you divide both sides by one thing. That's all you do every single time. So in this case, we divide both sides by 2 molar to get V1 by itself. We get V1 equals 0.3 molar times 0.5 liters divided by 2 molar. Right? Then, with your handy-dandy calculator, you take parentheses 0.3 times 0.5 parentheses divided by 2, and you get 0.075 liters. And we'll use 2 decimal places, so we round that to 0.08 liters. All right, that's V1. It's just some algebra. All right, so write down these steps. All right, you're going to want to write these down because it's the same way every time for all these problems. You just rearrange the equation. That's all you're doing. You move one thing over to the other side and you do the math. All right, with that in mind, let's take a look at the practice problems. All right, 2 practice problems. First one, I want you to try and work out the same problem we just did without looking at your notes. Second one, I want you to look at your notes and solve this problem. What volume of a 3.0 molar Ki solution would you use to make 0.3 liters of 1.25 molar Ki solution? So our M1 is 3. Our V1 is our variable, M2 is 1.25, and V2 is 0.3. Now, keep in mind, you'll notice it says like CaCl2 and Ki. When it comes to diluting things, it doesn't matter at all. If it gives you molarity, it doesn't matter. All right, it doesn't matter what it is. It works the same way every time. So you got to rearrange the equation both times. It's the same way both times. So I want you to pause the video, try and do the first problem without your notes, try and do the second problem with your notes. Take 5 or 10 minutes. Then we'll take a look at the answers. Great. Here's the answers. All right. The first one, 0.08 liters. We worked through that on the previous slide. The second one, it's 0.13 liters. Here's why. You get 3x equals 0.3 times 1.25. So that means x equals 0.3 times 1.25 divided by 3. And when you plug all that into your calculator, you get 0.125 liters. And since we're doing 2 decimal places, it rounds to 0.13 liters. All right, pretty straightforward, I think. So that's molarity and some molarity math, including diluting molar solutions. You're going to have a homework today over molarity and diluting molar solutions. This homework will be on campus, and it will be due at the next class, which will be a Wednesday. So let's take a look on how we find that homework. All right, remember, in topics here in online learning, you can find the slides and links to these videos, but your homework is in assignments. Now, for me, since I'm recording this ahead of time, the homework is in future, but it will be in normal. You click on it, you click on the link to the homework, it'll bring you here, and we got some problems over molarity. We got a molarity problem, a molarity problem, a molarity problem, and then a diluting molar solutions problem. All right, so that's 4 questions, 4 points, 3 molarity problems because they're very important, and then 1 diluting molar solutions problem. So you have the weekend to do this, but guys, it's Friday. Just get it done right now. Don't worry about stuff over the weekend, right? If you got to push it off till Monday, get it done. Don't wait until the night before to do this. You need to enjoy your time home alone playing Skyrim and Fortnite and whatever else you do. So there's your homework. I'll see you next week. Make sure to wash your hands for 20 seconds with soap and water and stay inside.